Unit 4, Section 2, Solving Systems of Equations by Substitution. Again, our idea of this is to find where our two equations intersect each other. Our first step is to solve for a single variable. Our first equation, y equals 3x, is already solved for the variable y. So we need to go through and use our second equation, x plus y is equal to 8. I'm going to take this 3x and replace it over here with this y. I'm going to be substituting the 3x in for the y. So I'm now going to have x plus, and instead of y, we're going to put 3x, and that's equal to 8. At this point, we only have one variable in our equation, so we can solve. So we combine like terms. 1x and 3x gives us 4x is equal to 8. I now divide both sides by 4. We see that x is equal to 2. So x equals 2. I now need to go find my y variable. In order to do that, I go back to my other equation, the y equals 3x, because the y is already isolated. I plug my 2 in for the x, so I'm going to have y is equal to 3. I'm going to, instead of an x here, we're going to place our 2. 3 times 2 is 6. So my y equals 6. And there's the solution to our system of y equals 3x and x plus y equals 8. That's the point where these two lines intersect each other. Looking at example 2. In example 2, we have 2x plus y is equal to 9, and then x equals negative 4y plus 1. So x equals negative 4y plus 1 is the one we're going to put in this column. It is already isolated. We have the x isolated by itself on the left side and everything else on the right. I'm now going to use 2x plus y is equal to 9. I'm going to take my negative 4y plus 1 and replace this x with it. So I have 2 times a negative 4y plus 1 plus my y equals 9 left over here. I now must distribute my 2. So I have negative 8y plus 1 plus y equals 9. Combine my like terms. A negative 8 and a positive 1 gives me negative 7y. Whoops. This is not supposed to be a plus 1, is it? It's supposed to be a plus 2. So this is the plus 2. So when we distribute, we have to remember to make sure we distribute it into both pieces inside the parentheses. And this is equal to 9. Now, we subtract 2 from both sides. Negative 7y is equal to 7. We divide both sides by negative 7. And we find that y is equal to negative 1. Negative 1. I now go back to my other equation, x equals negative 4y plus 1. I'm going to replace the y with my value I just found. So x equals negative 4 times negative 1 plus 1. Negative 4 times negative 1 is a positive 4 plus 1, and 4 plus 1 is 5. My x equals 5. This is the point where our two equations cross each other at 5, negative 1. For example number 3. Here we have b equals 2a minus 1. So that's the one we're going to go through and get isolated. b equals 2a minus 1. My other equation, I have 5a minus 3b is equal to 0. I'm going to take my 2a minus 1 and come over here and replace my b variable with it. I have 5a minus 3 times 2a minus 1, and that's equal to 0. I now must distribute this negative 3 into both pieces, again making sure we multiply both pieces by the negative 3. So I have 5a minus 6a plus 3 is equal to 0. I combine my like terms, my 5a and my negative 6a. That gives me negative a plus 3 is equal to 0. I'm going to add a to both sides so that I have 3 is equal to a. So a equals 3. I now have to go and find what does b equal. I go back and use my other equation, 2a minus 1, b equals 2a minus 1. I replace the a with a 3, so I have b is equal to 2 times 3 minus 1. 2 times 3 is 6 minus 1. 6 minus 1 is 5. b equals 5. At any point, you can check your answers by replacing both of these in our original equations and making sure that they come out to true statements. Good luck.